Hey, in this video, I'm going to graph two different logarithm functions just to give some more clarity about how these are graphed. All right, so we'll start off with graphing f of x equals 2 plus log base 2 of x. So in class, we've already seen what the graph of a logarithm looks like. We know that it has a vertical asymptote at 0. So then we'll just label two important points for the parent function. First one is at 1, and the second one is at 2, because 2 is the base. And then we'll only need to label 1 right there, and then for later we'll need, I guess we'll need 2 and 3 for later. All right, so we have two facts about our logarithm function, 2 points that are easy to evaluate. So log base something of 1 is always 0. Since we're looking for the solution to 2 to the what equals 1, that tells us that x is 0. And then 2 to the what equals 2, well, that has to be 1. So whenever a base to something equals that base again, that tells us that the x is 1. So we'll label those two important points. So we have 1 comma 0 and 2 comma 1. And then we just sketch in what the logarithm looks like. We draw it where it looks like it's almost flat, even though it will go off to infinity. It just goes very, very slowly. All right, and now we just need to handle this vertical shift of +2. And so we'll just take our two important points and just move them up 2 units. And then sketch in what the graph looks like. So there we go. This green curve is 2 plus log 2 of x. All right, for our second one, we're going to graph 3 minus log 10 of x plus 1. This one has a lot more transformations, but it's nothing that we shouldn't be able to handle. So we'll start with the coordinate axis. We'll put the frame for our important points. Let's see, it seems like we're going to be shifting up 3, so we'll have a 1 there, and we'll need to go all the way up to 4. All right, so for just the parent function, log 10 of x, we can just label these important points at 1 comma 0 and 10 comma 1, and sketch in the curve. So this one's going to grow even slower than the 2 to the x, since now it doesn't reach 1 until we're all the way at 10, whereas the log base 2 reached 1 at 2. Okay, so this, now we have an x plus 1, so that's a leftward shift, which actually shifts our asymptote as well. So now at -1, we have a new asymptote. And we'll just mark our important points, which we just shift over 1. So we have 0, we have 9, and we just sketch in this green curve. That should be slightly above. Ever so slightly. So there we go, just shift it a little bit. The next thing we have to handle is this minus sign. And so if we remember, the minus sign just tells us to reflect. And I'm actually going to start a new, I'll do a new axis for the next curve. This one won't be too hard to reflect because it passes 0. So on the left of 0, we just reflect up. And on the right of 0, we just reflect down. So there's that. We're still hitting 0, and at 9, we're hitting, that's now -1. And for our final curve, draw a new axis. So at -1, we have a vertical asymptote. Let's see, our 0 is going to get shifted up to 3. Where we were at -1, that'll get shifted up to 2. Over here at 9. And I'll put 9 actually below because that'll work just a tiny bit better. So we label our important points. It's now 0, 3 and 9, 2. And we just sketch in our curve. And there we go. This is 3 minus log 10 of x plus 1. All right, I hope that was illuminating. See ya.